see how quickly we can move through this. And if we can get a GraphQL query rendered to the page before the hour is up. So I'm going to jump right in. I have an empty directory right here that only has a README file in it. And I'm within my PPBL course. So there's a few things I can reference here. So I might want to jump into the front end template for a few minutes today, just to look at how things work there and to maybe even copy some code over from there. But first, let's just create a brand new project. Now you can use npx. We've been using yarn in this course, so that's what I'm going to use. So we can use this, and then I'm going to add the TypeScript tag. TypeScript is a bigger topic, but it's the right choice for us here. Okay, and let's just call this, I'll give it the same name, NextJS Cardano queries. And as we go through this, just stop anytime, okay? When there's confusion, just let me know. And I hope to highlight, I mentioned some of those gotchas that have to do with the way Next works. I'll try to highlight some of those as we go. All right, so that just created a new directory with the same name. So I'll cd into that. And here we are, right? And so from here, maybe this is familiar to you already. I can run yarn dev. And then I should see the basic Next.js starter template, okay? Now, what I typically do, whoops, a little window management, of course. I'll just move that over there. How about that? That's easier. Okay. So what I'll typically do is open up the new project right away and just go into that index page and just remove everything. I'm just going to delete all of that and then give myself an H1, hello world. And if I navigate back to the browser, there we go. Okay, just blank text on a screen. And obviously there's a lot more I could do here in terms of setting up styling like chakra, or just anything to make this thing more usable, like setting up a nav bar. But I'm not going to do any of that. All I'm going to do is right here on this page, try to implement a basic GraphQL query so we can have that full end-to-end example. All right, so that's item number one. I created a Next app. Now there's a few dependencies we're going to use. And the one that we chose to use in the stack for this course is Apollo. And so you can visit these docs on your own. The Get Started links, they show you how to install Apollo client. And it requires GraphQL as well, which is great because that's what we want to use. And anytime you see npm like this, you can just replace that with yarn add, and it'll do the same thing as npm install. So let's just follow that step. I'm actually going to turn off the server for a moment. I'm going to say yarn add, and then I'm just going to copy from off screen those two dependencies. And just in case you're new to how a JavaScript project works, we've got this package.json file that shows us all of our dependencies. And when I run this yarn add command, watch what happens to these dependencies right here. Okay, so now those two things I just added, Apollo client and GraphQL, are in the dependencies list. And when you download somebody else's project, or you git clone someone else's project, the reason you have to run yarn or yarn add or npm install after you do that is because it's then going to look at your dependencies list in the package JSON for that project, and it's going to actually download all of those dependencies, right? To save space in a GitHub or a GitLab project, we don't send along all of the files because these can be downloaded as needed. And that's what happens when you run that yarn add or npm install step. All right, so I've got those dependencies set up. The next thing I have to do is specify where I'm going to be querying data from. And the best way to do this part is just to review how it works in the front end template, and then just to copy some of those changes into this project. What we're going to look at is this underscore app.tsx page. And this is basically the wrapper for our entire application. Okay, you can see function my app. And what does it do? It just returns a component with whatever, right? Whatever page props you might have inside of it. Now, this is a really convenient feature of Next that allows you to very quickly wrap your app in whatever services you might need, because then they'll just be accessible at a global level. So this is what it looks like out of the box. Let's keep this one open. But then let's look at the same file in the front-end template. So I'm going to go into Pages here, front-end template, Pages. And let me know if my font size needs to be bigger. I like having a lot of space on the screen, but if this is too small for anybody, just say so. Here's this app.tsx, same file name. But notice that this one has a bit more going on. Let's put these side by side for a moment. Okay, this is the front-end template currently. This is what's out of the box. So first of all, I got rid of the global styles because I wanted to replace them with Chakra, which is just one example of a component library that just kind of takes off your plate a lot of design. And if you've been looking at the front-end template, it's not like anybody has spent much time on design there, but just even the basic box components, padding and color, just being able to do those things quickly. I appreciate that when design is not my goal. So that's why I use Chakra. There are plenty of other systems that you can use that are similar. We also wrap the entire project in a wallet provider, and this has to do with mesh integrations, or this design pattern would apply to whatever libraries you're using to integrate a wallet. But the most important thing to notice here is that both of these, a Chakra provider and a wallet provider, are now wrapping the entire component. This piece right here, component page props, there it is. It's still right there in the middle of the page, right? Render whatever is passed here. But around that, we can just add a little bit of padding to the whole page, narrow the width a little bit. We can throw a nav bar or a footer above and below that main component, and then we can wrap it with whatever we need. And the thing we're most interested in using to wrap today is just the Apollo part, right? We're not going to redo the styling or the wallet integrations, but we are interested in using Apollo provider. So let's do that. Let's just grab that line right there and import Apollo provider. And what Apollo provider requires is a client. Now here, that client is kept in a separate file. Okay, so ... one directory up from where we are right now. And then I'm looking for a file that's called Apollo client. There it is. Let's take a look at that. It's not a complicated file. It does make a couple more imports from Apollo client, right? Instead of the provider, we're importing a client and a memory cache. This kind of allows you to save some data in the user's browser. And then we look at, okay, well, where are we querying? In this case, we want to query from Dandelion testnet, the GraphQL server. Now, I don't have to put all of this in a separate file and import it. I can just take this and put it here. And so for brevity's sake, that's what I'm going to do. I'm just going to add these two imports to my app ESX. I'm going to add this client here, right within the same file. And then I'm just going to go back here to look at the syntax. How did I wrap it? Well, first of all, I'm going to want to add some parentheses because there's more than one line being returned now. I do want an Apollo provider, and provider takes client. And then we're just going to put the component inside of that. Okay. Any questions so far? So what we have now is we haven't changed the site at all, right? If I save this change and I go back, I'm going to run yarn dev again. And I'm going to head back to my app. Nothing different on the page right here, right? All I've done is I've prepared myself to be able to make a query that can then be rendered to the page. And I should say, not just the page, but any page in the app, because we're wrapping the entire project in an Apollo provider, right? And anytime it tries to make a query, it's going to know that that's a query to this URI right here. If I wanted to make an app for mainnet, all I would have to do is change the word testnet to mainnet. And that's the elegance of this, right? If I have a bunch of working queries, I test what I want to do on testnet. And then when I'm ready to deploy, that's all I've got to change for those queries to now apply to mainnet. So how do we use that client to actually get some data? Well, I didn't bother creating a separate file for this client and importing it, but I do think it's good practice just to think about this design pattern for how we create additional components in a React project. So Next takes care of a lot of stuff for us. Without a framework like Next, there's a good bit of work you have to do just to create routes, the ability to have a JavaScript or a TypeScript file, and for that to be rendered as a page with its own URL. Next is convenient because it takes care of that for us. It provides this pages directory, and then I could just make pages with whatever name I want in that directory, and I'll be able to go to localhost / that page name. And you've probably seen that already if you've been playing with the front end template. Now in a separate folder from the pages folder, I can build components. That components folder is not provided out of the box because there's a few different ways that people like to organize their projects, but it's a pretty common design pattern just to make a top level folder called components. So that's what I'll do. And in this, I can make a new folder. Let's just call this example GraphQL query. Call it TSX because it's a TypeScript file. Okay. And then just some boilerplate. And I'm just going to refer to the template once again, just to grab some of that boilerplate. Here is, oh, those are transactions. This one, this is a working component that's already in the front end template. I want to build this piece by piece, but just to look at the basic format, first of all, I am going to want, I'm not even using Chakra right now. Well, let's just do this. So, right, I just want to export a default function with a name, and I want to return something. Let's just do that part first. I'm going to call this example GraphQL query. And inside of it, we can just, once again, okay, so that's going to say make a query. Now, what I'm able to do here is in my index, I can import that. And I could start importing it here. What's nice is if you have your code environment set up, you can just start typing the name and autocomplete will show it to you and it'll import it automatically. And the reason I have an error here is I have to wrap all of this in something. I can't have two different top level components. So now they're wrapped in one and we're returning just one component on the page. All right, now if I save this and jump back over to my page, I've got the H1 hello world, but then I've got this other component. And the other component, remember, it says make a query in it. So that's what we see right here. And what this means, this is just kind of nice pattern so that you're not writing a whole bunch of logic directly on a page, but your pages are staying relatively kind of clean and easy to read. And then that component is where you can do all the messy work of making something work. So I'm actually not going to touch this index TSX file again. I'm just going to be working within our example query for the rest of this session and trying to make it do something. Any questions at this point? All right, so we are ready to go. Now I put thinking about rendering methods in NextJS on the page here. This is a big topic. And so just to give it a very short treatment, Next is really user-friendly to use to get started with it. And it's pretty powerful, the choices it gives you. So out of the box, it provides a variety of rendering methods. And I shared this link with Nelson and maybe some other folks saw it last week. This one right here is the best post I know for thinking about these different rendering methods, okay? Static, incrementally static, server-side rendering, and client-side rendering. And essentially what this allows you to do is to say, okay, well, some of my data is never going to change, or at least is going to change pretty infrequently. So we can just grab it at build time, right? And it can just, there we go, it's ready to go. We don't have to be querying some service every time we run that thing. Of course, most apps are more dynamic than that, right? The whole point of using an app is to have up-to-date dynamic data. So we can use static regeneration and pay attention to when the data changes. We can grab the data every time we render a page, and all of that can happen on the server side before we send a page over to the user or the client. Or we could have the user's browser perform the query so that we're not grabbing the data first and then passing it over to them, but we're allowing their internet connection to do the heavy lifting of grabbing the most up-to-date data. And you can kind of see as you move down this list of options, it grows more dynamic each time, right? This is minimally dynamic, incrementally more dynamic. This is dynamic in that we can update the data every time we build a page on our end, wherever we're serving from. And this one is for the most dynamic sort of data that should be just rendering in real time, right? So if you have a game or a live dashboard, you're probably going to want client-side rendering. I'm giving this a really cursory overview just in the interest of time. This is a much deeper topic. There's a lot of documentation on NextJS about it. But like I said, I think this is a really good blog post to just wrap your mind around it for the first time and to see some examples in action. Okay. So, he goes through kind of the overview of what each of these is, probably better than I just did, takes you through some of the steps that I've already taken you through, okay? And then finally going through these 4 methods. All right, but instead of relying on that, let's just look at the syntax of a component that already does this. And this is once again from the front end template. So we can ignore this part. This is just for styling. We're very interested in this query right here. This is what we want to do. And we're going to circle back to this in just a moment. And then we've got the page itself, right? The function that represents the page that we're trying to render. Now it doesn't get to the return right away. So everything right here in the return is what actually gets rendered to the page. But you're often going to have some helper functions within that to handle data. So let's look at this piece first, and then we'll look at the query. So this part right here, this is the best thing that Apollo provides, in my opinion. Okay, there's a lot of convenience that we see. So what's use query? Well, that's imported from Apollo client. Okay, so that's a hook that's written by Apollo client. Maybe you've started to see use state or use effect in the front end template. And if you're not, if you've never used React hooks before, don't worry too much, but just know that's another big topic. There's a few hooks that are provided natively by React. And then if you are, if you're really writing your own projects in React, you're very likely to write your own hooks. In fact, when we start using the wallet to build transactions in the front-end template, you'll see another example of that kind of hook. So Apollo provides one, use query. And what's great about use query is it takes care of a lot of boilerplate for us. What can happen when we query any network for data? Well, One thing that can happen is we actually get the data that we're looking for. Another thing that will happen, at least momentarily, is that data will be in a loading state, and we might want a way to report that to users. Finally, errors can happen. There's all sorts of things that can go wrong, whether it's a network issue and you can't actually get the data, or there's something wrong with your query, right? There's plenty of errors that can happen, and you really want to be able to read them as quickly as possible. So error reporting is essential, and this use query takes care of it for us. What we have to pass to use query is the query itself. This is an arbitrary name, right? The only reason I use the word query right here is because that's the name of this constant we built that holds the GraphQL query inside. I could just as easily change it to banana if I wanted to. Okay. And then the second parameter is this object right here. Okay. We have a query and then a comma and then an object. And inside of that object are any variables that we might want to pass to our query. That's optional. Well, it's optional to use variables. I guess I have a variable here, so I have to use it, right? And look at the name of the variable. It matches the one in my query. But you might also have just a static query with no variables in it, and then this use query line would only look like this. This syntax is just a really nice convenience of JavaScript. It's called destructuring your data, okay? So instead of taking just one variable and setting it to a value, we know that use query is going to return an object, and we know that that object is going to have these three different variables inside. So we just say, yeah, give me all of those. And now I can use the word loading elsewhere. I can use error elsewhere because it's coming right from the query. And then finally, I can use the data. Where did I put that? TX. Oh, here. Right. Sorry, I was just remembering what this one does. So here, right? If we get data, take it, look at that data, and then look inside for the transactions. There's likely to be more than one, and then map them. Again, lots of big topics here. Mapping over an array is another topic. Maybe we can circle back to that one too at the end of this hour if we get that far. But I want to highlight first just this piece, data.transactions. Okay, let's go up and look at the query itself. As a variable, it takes a policy ID, and we happen to be passing it this one. This is the one for the PPBL Summer 2022 token. And we say, okay, go look for all of the transactions where the output held a token with the policy ID equal to this one. Go get a list of all the transactions where these PPBL Summer 2022 tokens have ever been included, have ever been sent to someone else, and return that list of transactions. So that's like our filter. And you could do this for any policy ID. Even if it's a token that you didn't mint, if you want to track the movement of any asset on a Cardano network, this is all you need to do. Query for all the transactions where that policy ID was in and output. Now, for some assets, that might be a really long list. And GraphQL offers pagination and limits, which are just ways to not take all of the data at once, right? If I looked at Hosky tokens on mainnet, how many transactions have there been with Hosky tokens? I don't know, right? It's more than I would want to render to one page. So maybe I would add a limit of just the last 10 of them or the last 50 of them even, all right? And that's all built into GraphQL, but it's going to be beyond the scope of what we're doing right now. The other thing that GraphQL allows you to limit or basically kind of surgically ask for is what data you want to get, okay? So each of these is a field. We say, look, don't give me all of the information about those transactions. Just give me its timestamp, which is included at, and show me the outputs to each one. For each of those outputs in those transactions, show me the address that the output was sent to and the list of tokens included in those outputs. Notice that we're not asking anything about inputs right here. We're not asking anything about metadata right here. We're not even looking at the amount of Lovelace in any of these outputs. We could. There's good reasons to look for metadata or to look at inputs or to get the Lovelace value of a transaction. It just depends on your use case. And in this case, all of those are left out. So let's go over here. Here's our GraphQL Playground. And maybe some people have had a chance to play with this a little bit. Wait a minute. I have an invisible window over my screen, sorry. Okay, that's better. But this is where we can check that our queries work, okay? So let's just make a new one. Copying from VS Code that particular query, right? And this requires a variable, which we would just put in the bottom down here. And you can actually just start typing and it'll autocomplete for you. That's a really nice thing about the GraphQL Playground. Let's see, token policy ID. Yeah, let me grab that one for the summer 2022 token. And so that means that I'm now looking at this policy ID in this query, and let's return those results. If I got rid of included at, like this, then included at would not be included, right? If I got rid of the quantity and I just wanted to, I don't care how many of these tokens went to each place, I just care the addresses they went to, I could look at that, right? If I wanted to know some inputs, I could add those. I could say inputs, and I could say, yeah, where was the address each of these inputs came from? And I could run that query. And now each transaction, right? So this is an array, square brackets, around a list of transactions. And this right here, everything from this first opening bracket, oh, nope, it keeps going. Still going. Yeah, okay, this is a long one. It would go all the way down to here, basically. But this, what I'm trying to show you here is that this data consists of an array of transactions, each of which is an object that has an array of inputs and an array of outputs. Actually, just to make this even easier to look at, let's get rid of the token bit and let's just do this, right? Let's only look at input address and output address. And it'll be even easier to see, okay? So transaction, is an array of these objects. There's a complete object right here, and then a comma, and then the next object, and so on. Now, the reason I wanted to show you this is because now, if you're familiar with JSON or plenty of other programming languages, the dot operator is going to be important. And so remember a few minutes ago, we saw in my example query on the JavaScript side, data.transactions.map. Data.transactions.map, right? Well, the reason we're able to do that is because that's exactly the format of the data we're getting. The top level object is called data. In it is an object called transactions. And that transactions is an array. And anytime I have an array, I can map over it. And mapping just means run this code on each element in an array. So if I had an array that was just, 1, 2, 3, 4, 5, and I dot mapped it, right? I could then take each number in that array, and I could say number +2, for example, okay? And what this would do is it would just add 2 to each of these numbers here. And so the result of something like this would just be 3, 4, 5, 6. Now, usually we want to do something a little bit more complicated than that. But actually, in this case, it's not that much more complicated because I'm not actually doing much with the data yet. In fact, I'm just grabbing it, raw data, and stringifying it just so I can see it on the page. Nothing too complicated here, okay? I could further look at the shape of that data. What does each transaction have? It has a dot included at. It has a dot outputs dot address. It has a dot outputs dot tokens dot asset dot policy name. I could look at each of those fields individually, and then I can use those to populate a much more interesting front end that actually shows me how to do something. So let's see if we can get there.
James, can I make a quick, simple question?
Of course, of course.
So there in that example on the map, like you specify what to get, and in your most basic example, you put in number, which I guess is some keyword there, or are you just labeling each element of the array?
Excellent. Exactly. Good. No, that's such an important question. This is an arbitrary name.
Okay.
That we're going to use to represent each item in the array. Okay.
Okay.
So this
TX is also arbitrary. You just
it could be a banana, right? Okay. Map over these. Each one of those, call it a banana. Add 2 to that, whatever it is.
Okay. Awesome.
Each item in this array, let's call it a transaction because that's a reasonable thing to call it, right? Yeah. And then what do we do for each of those? Just stringify it and render it inside of a purple box.
And then just since we're here, that 2 dots and then any, what does that do?
This right here, this is TypeScript, okay? And actually it's bad TypeScript. Any is like your wild card. So watch this. If I get rid of that part, I'm just going to have TypeScript complaining at me.
Okay.
And
so you have to specify some type for each of those elements in the array. And you're just saying like, yeah, it's something. You don't care. Yeah.
Okay. The more rigorous approach to this bit right here would be to specify exactly what we expect to get right here. Okay, and
Gotcha.
we'll go deeper into that
Uh,
later. But yeah, just to save time when you're building quickly, any is a fine option.
Right.
But if you're dealing with other people's money, it's probably worth time checking, you know?
Yeah. Awesome. So in the last very simple example, so it would be number dot two dots int or something like that.
So it's a data type that you have to define there.
Yes.
Right.
Okay.
I would say number.
So
would-
banana number, yeah, or int or yeah, whatever
Right.
types.
Well,
of
and
use. Awesome.
TypeScript only provides number, so it's the only
Okay.
option you have.
Right.
So then the other thing about TypeScript is that if I do something like this, notice that it's not complaining right now, because if I try to add 2, it just assumes it's a number and therefore I don't have to say it. So that's why TypeScript is funny, is that if it's not obvious, it will complain. But anytime your code already makes it obvious what that type is, it's going to be fine with that.
Awesome. Thanks.
Yep. Although actually watch this. Like if I said, well, never mind. No, that's more TypeScript. We're not gonna worry about that. Okay. Racing the clock to get a real query on the page. Does anybody have a query that you would be interested in seeing? See if we can write it real quick. This is the one. Let's just use this one just for fun. Well, that one's boring. You've already seen that one. Let me just query an address. Let's do this one right here. Okay, let's query just be able to query any address, maybe not the wallet I have. Maybe this could be a contract address. So let's call this right here. Let me just check my syntax. Yeah. Good. Let's have a variable called contract address. And then I can do an anonymous query right here when I'm just testing things, but let's call this will be our contract query. Which is going to take one variable called contract address, which is going to be a hash 32x. Or is that just a string? Yeah, no, contract address might just be a string. Well, it'll tell us if we're wrong. But let's start with string and see if that works. Okay. I just want to see the UTXOs at the contract address. And let's not even worry about the tokens or value they hold. Let's just get the UTXO hashes and indexes first. And does anybody have a contract address lying around?
Not answering your question, but can you do a stake, just a stake part of an address?
I think I have the docs open. So this is the entire GraphQL schema. Oops, pretty fun to navigate it, but luckily you don't have to only go visually, you can search. Stake registration, that's not a stake address. I'm not sure. do a payment address. So here's an active stake dot address. That might be what we're looking for. Is a stake address. Yeah, so we can.
Cool.
All right, I've got a little bit of a busted contract address over here because I was playing a few games with the front end. Can't wait to show you guys this. And apologies that all of the mini project isn't released yet, but more on that later. But here I have a contract address. Let's see if this works. Yeah, good. Okay. Very simple query. This shows me data.utxos, and it gives me the hash and the index of each of the UTXOs that's currently at this address. So how many are there? 1, 2, 3, 4, 5. Okay. And then once I have these UTXOs, well, I could do other stuff with those, right? Maybe I could make, did I have that's a policy ID. Look, I could take that transaction hash and I could then, if I want to, get all sorts of information about each of those. So think about mapping over the results of a query with an additional query. That's possible. But this is good enough. This will show us just some results on a page and then we can play with it. So what I'm going to do is I'm going to take this query exactly as it's written in the playground. No change necessary at all. And I'm going to head back over here. I'm going to look at this syntax right here. I'm using GQL from Apollo Client. And the way GQL works is it actually uses backticks. I've always wondered why they had to resort to backticks, but I guess a lot of the other operators, right, enclosures are used. So for GQL, we get backticks, and everything in between is going to be exactly what I just copied from the playground. The name of the query is arbitrary. So this doesn't have to be exported, right? So some new query is going to be equal to GraphQL backticks, and that's going to give me a hard time for just a moment because I need to import GQL as well. All right, and if I really want to be, yeah, that's good enough. All right, let's also grab this import right here and put it at the top of this component. All right, cool. So now the last thing we're going to need to do, all right, if I go back to my local host, oops, that's the wrong one. There we go. If I go back to my local host, still unchanged, because it just says make a query right here, but we're about to change that. And let's once again look at the template. This is how I'm just going to copy this part right here, because this is going to be mostly boilerplate. And this actually goes inside of my page function. All right, notice this query is outside of the main function, but this use query goes inside. Now, the variable is not called token policy ID, it's called contract address. And I can set that as a variable elsewhere, or I can just type it directly right here. I'll just place it directly this time. Okay. And I got to change the name of the query. All right, but no problems right now. This should work. Let's just make an H2 that says query results. And then let's make a paragraph that has a JSON.stringify of data, whatever data turns out to be. Now this is yelling at me because these are 3 top level components. Once again, I can just wrap them like this and that error goes away. All right, but here's the big moment. Let's save this and hope it works. Back to my local host. Oh, JSON, yeah, of course. I wrote the words JSON stringify data, but they need to be wrapped in curly brackets. Curly brackets within what you're rendering allow you to access your JavaScript variables from inside of the basically HTML. And that's what, if you ever see JSX or TSX, that's kind of, long story short, that's the language that allows us to kind of write JavaScript and HTML within the same file and to pass variables from outside of our return into the HTML that it's rendering, like you see right here. All right, let's save that. Now that's a variable that ought to be rendered. And when I zip back over here, we do see it. It's ugly, but it works. So let's try to make this a little bit prettier real quick, okay? Because right now, all I have is this top level result of UTXOs. What if I could map over those UTXOs and render each one at least on its own line? Let's do that. Okay. So instead of just stringifying all of the data, this time I'm going to use curly brackets again. I'm going to say data.utxos.map. We'll call these apples. And for each apple, oh wait, I don't want this to be, I got ahead of myself. That paragraph is going to go inside. I want to print a new paragraph for each of these. Okay, and let's just JSON.stringify each of those apples. And that's complaining, but it's just because it needs a type. So I can use the any trick. All right, so now if I save this, here's the result of that first. Just stringify everything. And then here's the result of the mapping. Okay, well, what if I just wanted this to be a nice list of transaction hashes and indexes in the format that I usually see them on the CLI? I can do one more thing here. All right. Instead of just stringifying that data, think about what's inside of each of those apples, right, or transactions. I could say apple.hash, and then I could do a pound sign, and then I could do apple.index. And if I did this right, no, it doesn't like that. Oh, because it's transaction.hash. Okay, so apples.transaction.hash. There we go. All right, so that mapping now results in these strings that might look kind of familiar to us. Maybe I would want to wrap those in a pre to make the text equal width. And there we go. Nelson, what do you think?
Yeah, I just wanted to ask, is there a way so that we know what are the arguments or properties of the data itself? Like, is there a way to know all, like, data transactions, UTXOs, and what else are possible? Like, can we get a list of all the available options?
So the best list of all those options is actually this site right here. Okay, this is the entire GraphQL schema. Okay. Now, right, that's a lot to navigate, but it's worth it to kind of search for a few things you're curious about and see how these objects link together. Right, so there's going to be some dynamic links inside of each of these options that shows you how data relates. And then as you start to get familiar with that, the best thing to do is to play around and to say, okay, well, if I can query UTXOs, what's another thing I could query? And the beauty of this GraphQL Playground is you can just start typing and seeing what your options are with the autocomplete. Okay. Or within an existing query, you can just start typing and you can look at what else might be available there. So value, ooh, I could use value. Let's see. Good. All right, that adds Lovelace to the transaction or to the query. All right, so GraphQL allows us to have this really fine-grained control over what data we're grabbing. And then, because we've already thought about that, watch, let me just add value right here to our query. And then let's add a space. Well, that's pre, so let me do this, watch this. I'm going to put this once again in a paragraph. I've got the UTXO itself is pre-formatted, but then I'll write has apples.value. And then outside of that, write the word Lovelace. And then go back to my query over here. Oh, I broke it somehow. Of course, it stopped working right at the end. What did I do? Data.ut. You see, now I'm in a hurry. Was I not allowed to put value there? Oh, there's the value. UTXOs.map. This always happens right when I have to. I have another meeting right now, but I just really want to figure this out. There we go. Well, I don't know why that wasn't working for a moment, but here's what we're mapping through, right? UTXO has this much Lovelace. UTXO has that much Lovelace, et cetera, et cetera. Again, super simple example right here, but my goal is for you to kind of just have the high level idea. All right, we recorded this one. I have a 30-minute call that started about a minute ago. I got to jump over to that. But thanks for spending this time today, and I'm looking forward just to hearing follow-up questions tomorrow when there's time. Thanks, everybody.
Thank you, James.
Thanks. Bye.
Cheers. See you soon.